So we are learning now our trig ratios. So we are in the trigonometry section of geometry. So there are 6 trigonomic ratios. So sine, cosine, tangent, cosecant, secant, and cotangent. So I recommend memorizing the 6 functions in this order because we're going to be doing the ratios, and the first 3 are opposite of the second 3. So that makes it a little bit easier to remember. So the first thing you want to do is memorize this little acronym, I guess it's called, or just a little cheat sheet. SOHCAHTOA. So O means opposite. H is hypotenuse. Sorry if I misspelled that. And A is adjacent. All right, so I mentioned that the first 3 trigonomic ratios, these 3, are opposite to these 3. So this first letter is sine for the first one, C is cosine, T is tangent. So if we flip the order of OH, for cosecant it's HO. So this one would be H over O. And then cosine is A over H, we would do H over A. And then for cotangent for tangent it's opposite over adjacent, so we would do adjacent over opposite. So they're the exact opposite. I'll write them down again in a second, but I just want to point that out. So what we're going to be doing is you're going to be given a right triangle. So these rules are for right triangles specifically. So I'm going to give you a right triangle, a degree, and then we're going to find the position that we need for each ratio. So this is my 90 degree, which is what indicates that it is a right angle, a right triangle, I mean. So first thing is, let me put a degree here. Let's do 37 degrees. So first thing is that no matter the position of the triangle, the side directly across our 90 degree box is always our hypotenuse. And then we have opposite and adjacent. So remember, there's 3 parts: opposite, hypotenuse, adjacent. Our hypotenuse again is always directly across our 90 degree box. And then for the other 2, you go by the position of the degree. So 37, opposite of 37 will be right across. So this would be opposite. And then adjacent means neighbor. So the neighbor is this side, so adjacent. So even though technically H is also the neighbor side of 37 degrees, that is always our hypotenuse. So hypotenuse is its own side by name. The other side is adjacent, the one that's right next to it. Not always to the left of it, it could be to the right of it, as long as it's not the hypotenuse. So opposite is across, adjacent is next to, and then hypotenuse is right across the 90 degree box. So let's do our first example. So these are going to have sides. So let's say we have 3, 5, and 8. So you're going to have a triangle, a degree, and the 3 sides, or you're going to be given 2 sides and we have to solve the 3rd side, but we're not doing that today. So let's say I want the 6 functions, so I'm gonna write these out this time. So we have so, ka, toa, which is what I have up there, and then we flip them for the other side. So we have sine of 37. So again, this is gonna be O over H. And then we have cosine of 37 degrees, because we always go by the degree. That's gonna be A over H. And then we have tangent, tan of 37. That is opposite over adjacent. And then let me scoot this over. And then we have cosecant, cosec. So remember, this is the exact opposite of sine. So we're gonna do of 37. So this is gonna be H over O, which is again the opposite of this one. And then we have secant of 37. So if this is A over H, we're doing H over A. And then last we have cotangent, C-O-T, cot. This is opposite over adjacent, so we're doing adjacent over opposite. And I'm gonna fill in those letters as we go through. So the first thing I recommend is that you label your positions just to make it a little bit easier. So I know that 8 is my hypotenuse because it's the one directly across my 90-degree box. And then opposite of 37 is 5, so we'll put O here. And then last we have adjacent, which is the neighbor of 37, which is 3. So we have A here. So now we're just gonna go through and replace the letters with the numbers that are in that position. So for the first one, we have opposite over hypotenuse. So O is 5, H is 8, which is our hypotenuse. So 5 over 8 is our answer for this one. And if you memorize it, the 6 functions in this order, the one right across from it, next to it, we know that it's the opposite, so we can just do the same but flip it. So 8 over 5. So you're getting 2 and 1 for each one. Adjacent over hypotenuse for cosine of 37. So A is 3, hypotenuse is 8. And then again, we can flip it on this side to get our answer for that one. Tangent is opposite over adjacent, so O over A, which is 5 over 3. 5 over 3, and then we can flip it, so 3 over 5. So again, if you memorize these in this, the trigonometric functions in this order, you can do the first 3, which is what this appears for, and then just flip it for the other 3. And that's basically, what we're doing. The only thing that changes is if there's 2 degrees on the triangle. So I'm gonna do one of those as well. I'm gonna erase. So if we have one that gives you both angles, the list will tell you which number it wants you to go off of. So let's say I want sine of 48, cosine of 42, tangent of 42, cosecant of 48, and secant of 42, and cotangent of 48. So it's the same thing we just did, but we have two opposites and two adjacents because we have two angles. So depending on which angle you're going off of, the opposite of that angle would be different to the opposite of the first angle. So our hypotenuse, again, we know it's always the one across our 90-degree angle. So let's say for sides we have, let's do 7, 12, and 6, something like that. So our hypotenuse is 12 because it's the one directly across the 90-degree box. I can't mark the opposite and adjacent for this one because again, there's two angles. So the opposite for 42 is 7, but the opposite for 48 is 6. So it just depends on what I'm asking for. So we'll leave those unmarked, but we're gonna go off of SOHCAHTOA and the opposites. We just have to go off of what it's asking for. So sine of 48. So going back to our ratios, sine is opposite over hypotenuse up here. So we're doing opposite of 48 over the hypotenuse. So I know the hypotenuse is 12. So 12. And then the opposite of 48 is 6. So 7 would be my adjacent for 48 in this case, but we're looking for the opposite, so 6. So we're going to take a second here because 6 over 12 can be reduced. So if you have, we always have fractions. You want to reduce the fractions that are reducible. So 6 over 12, we can divide it with 3 and get 2 over, actually no, sorry, we can divide it with 6 and get 1 over 2. So that's our official ratio, 1 over 2. And I can flip it here because it's asking for the same degree. But if I were asking for cosecant 42, we would not flip it because 48 and 42 are not the same angle. In this case, sine and cosecant are opposite of each other, and they're both asking for 48. So I'm going to do 2 over 1, which is just 2. So that one's done. Cosine of 42. Cosine is adjacent over hypotenuse. So again, my hypotenuse is 12. The number adjacent to 42 would be 6. The one across would be 7. So adjacent is 6 over 12. So it's the same thing as the one at the top. We're going to change it to 1 over 2. And secant of 42 as well is going to be 2, just like the top, because they both gave 1/2, and they're both asking for 42, cosine of 42, and secant of 42. But the last one is asking for the tangent of 42 and one the cotangent of 48. So we will not flip those when I do the first one. We have to find them individually. So tangent is opposite over adjacent. So opposite of 42 is 7. And then its adjacent is 6. So this is 7 over 6. And again, I am not going to flip it on this one because they're asking for two different numbers. So for 48, cotangent is still the opposite of this ratio, but we're doing A over O. So adjacent over opposite of 48. So adjacent is 7 over opposite is 6. So 7 over 6. So it ends up being the same because of the different positions of the angles. And then we just do the opposite of the ratio itself. But I didn't flip it to 6 over 7 for cotangent of 48 because we were asking for 42 here, 48 there. So it's not the same thing. And that is it. That is your trigonometric ratios.